This is page 38. Right, I am decreasing speed in the negative direction. So observe the motion of the cart slowing down after initial push. First of all, observe it without the motion detector. So let's see what's going on here. Turn this guy around. What we've got is we're going to give this a push. One more time, give it a push. The first thing I want you to do, I just need to, when I finish talking, pause the video and compare this question to question 2 on page 36. So pause now and compare it to question 2, page 36. So hopefully you've seen that this is exactly the same as 36. We give it a push. It goes up the ramp and slows down and stops. The only difference is this time I'm pushing it towards the motion detector, towards the 0 position, whereas last time I started here and we pushed it away from the motion detector. So it's still going up a hill and slowing down, but we're now looking at what's the difference if we've changed where the 0 position is. It started from the 0 position last time. This time it's going towards the 0 position. So the first things first, let's draw yourself a motion map. So pause the video now and draw a motion map, and when you come back, I'll go through what I think it should look like. Right, so I think the motion map needs to start here. I've given it a push, and we're looking at when it's coasting. So it's going quite quickly at the start, and it slows down as time goes on. So I draw my dots first, make sure that the spacings are right. In this case, the distance between each dot gets less and less. And then I'm going to draw my velocity arrows on. And these velocity arrows are getting shorter and shorter because my velocity is decreasing. I label them, really important I label them because we're going to do acceleration arrows here and we don't want to get them mixed up. Because my velocities are getting smaller, that means my acceleration must be in the opposite direction. Okay, because if my acceleration was in the same direction, if I was to do an acceleration arrow like this, that would mean my velocity arrows were getting bigger, and that's not the case. My acceleration arrows are going backwards, my acceleration arrows are going backwards, acceleration arrows are going backwards, and I want to show they're all the same size, so I put an equality mark on them. Is my velocity positive or negative? Well, my velocity is heading to the left, but my positive sign is heading to the right. So my velocity is negative. Is my acceleration positive or negative? Now this is, again, another tough one. I am slowing down. So I know some of you want to say that it's negative. However, it doesn't matter if I'm speeding up or slowing down. What matters is what are my acceleration arrows doing in comparison to which way the positive is. Positive's to the right, same way as my acceleration arrows. My acceleration is positive. This is something that's going to be a little bit tough to get your head around, and the only way I can really get my head around it is by drawing a motion map and explaining that even though I'm slowing down, I have a positive acceleration. Okay, the motion map helps me a lot. Now, once more, that's going to help. These both are going to help with the graph. And this is going to help with my graph. Knowing that my acceleration is positive is going to help with my graph. Knowing my velocity is negative is going to help with my graph. So can you pause the video, and it's really important that you make predictions. So pause, draw your predictions in the book, and come back to the video when you've done your predictions. Right, so let's see what these look like. Once again, when I go here, the first graphs you see are from last time, so don't get too excited that they're the answers. They're not. Right, I've got this set up so that it's got a trigger, and I want to erase this data. Yeah, that's good. Trigger's ready. Here we go. 1, 2, 3. Cool. So let me just zoom in on this position time graph and velocity time graph, because the one I just did only went about halfway up the ramp, but that's okay. We still get the right shape. Right, so it starts off with quite a steep, and then on the position time graph, and then it gets shallower and shallower and shallower. If I was awesome at pushing this, and it went right to the top of the ramp, this line would come closer to the 0 mark. So that's probably what you've drawn in yours. My velocity, you can see this bit here in that first 0.1 of a second, that's me pushing it. So ignore that. But my velocity starts off negative and it gets closer and closer to 0. It slows down. 0 is stopped, obviously. And my acceleration the whole time, forget the little first bit because that's my push, it's positive the whole time. So let me draw in what they should look like, especially let me draw in what they should look like if I was a good pusher and I made it to all the way to the 0 mark. So I started quite far away from the 0 mark. I ended back at the 0 mark. And I started with a fast speed and I ended with a slow speed. My velocity was, and I can see it from here, my velocity is a negative slope, and then it's still a negative slope, but it's getting closer to 0. So I've got a negative slope closer to 0. Is that what I had? Yeah. So there's my velocity, nice straight constant gradient. And my acceleration, even though this velocity is negative, the gradient is the whole time is positive. So if I used a ruler, it would be much better, but that's meant to be a horizontal line. So once more, pause the video and answer the questions on the side and come back and we'll check them. So the slope of my position time graph, well, it starts off steep and it ends up shallow, so it's getting less. It's a decreasing slope. But the whole time the slope is negative. And always the slope represents velocity on the position time graph. On my velocity time graph, the slope's the same the whole time. It's a constant slope. And even though my velocity is negative, my slope is a positive slope, which is good because that's what my acceleration is. And this slope represents acceleration. Great, thanks.